Thumb drive. Oh, nope, it's recording. There we go. Woohoo! It's about ready to give up on it. Okay, so let's first of all talk about this. Today's date, 4/26/21, right? Objective is really radian angles. Okay, so radians are an angle. Okay, radians are an angle. So we have two ways to describe angles, right? We have degrees and we have radians. If we look at our calculator, you'll see in your mode button, okay, go to your mode and you see two different spots. It says degrees or radians. So radians are angles, okay? So radians are angles. They are angles that relate to the arc length. Okay? It's really important because I'm going to give you a really easy example and you're going to see what I'm talking about, okay? Really easy example. I want you to watch this, okay? Draw 3 circles, okay? Okay, I'm going to draw 3 circles, right? Check it out. I'm going to draw 3 circles. In geometry, just watch, you don't have to write this down. In geometry, we would say if this was a 70-degree angle, then this arc length is 70 degrees. Not arc length, but the arc is 70 degrees, right? So in geometry, if we said that this angle was 70 degrees, we would say then the degree measure of the arc is 70 degrees. Wait a minute, that doesn't make sense. How can these two be the same? They are. And in geometry, we would say that if this angle, you kind of get where I'm going, was 70 degrees, in geometry, we'd say then this arc would be also 70 degrees. That doesn't make sense because this is a longer arc than this, which is longer than that, correct? So what we have to have is really a connection between the angle and the arc length, okay? And we do now. So 1 radian is equal to, 1 radian is where the 1 radian is where the radius and arc length are 1 unit, okay? So that this angle right here that I drew, this angle right here, that angle is 1 radian, not degrees. So this theta right here is 1 radian. Now it's about 57 degrees. Okay, it's about 57 degrees. So it's about 57 degrees. Okay. So now we have a connection. So now it says, okay, complete the unit circle for all significant angles. So let's go ahead and take a look at this. I'm going to pass out one more thing to you. The unit circle. Okay, I know you've never heard of unit circle, but when you leave this class, you move on to calculus and beyond. They will talk about the unit circle a lot. SAT has a unit circle in it. The unit circle is a pretty amazing thing, okay? Okay, so we are going to create this thing called a unit circle, and don't lose it, because this is, and if you do lose it, I guess we can recreate it, but try not to lose it, right? Okay, so then, let's check it out. So first of all, there is an equivalent. And you might need a ruler. You might need a ruler. I use colored pencils. But first of all, let's take a look at this. I have an equivalent. If I have 0 degrees and 180 degrees, okay? I know in radians that there's an equivalent between 0 degrees, 180, and pi. So this is also going to be pi radians. Same angle, because the arc length is 3.14, which is pi. If the radius is 1, okay, and then all the way back around to 360 degrees would be an equivalent of a 2 pi. 2 pi radians is an angle, okay? So the 90 degrees, and I don't want to get going too fast for you, then 90 degrees, which is up here, is going to be half of 180, right? 90 is half of 180, which in radians is going to be half of pi, or in radians we call it pi halves. So one angle, two different names. One angle, either this angle could be called 90 degrees, or this angle could be called pi halves, okay? Because the circumference of the circle has to make the same as the angle. Now, all the way down at 270 degrees, 270 degrees is the same thing as pi halves. Pi is 1.5 pi, but we'll call it 3 pi halves, okay? So one angle has two different names. It has an angle name of 270 degrees or a radian name of 3 pi halves. Okay, now we can also do this angle here. Okay, I'm going to just draw this angle. In fact, I'll draw it all the way across. Okay, I'm going to draw this 45-degree angle here, okay? So this is a 45-degree angle. But it's half of 90, so it's half of pi halves, which makes it, as a radian, pi fourths, okay? Same angle, two different names, okay? You with me? Same angle, two different names, okay? And then I can also have an angle way over here at 135 degrees, okay? I can also have another angle over here at 135 degrees, okay? But it's going to be a 3 pi fourths, 2 fourths, 3 pi fourths, okay? Radian. So we've got one angle with two different names. We have a name of 135 degrees or an angle of 3 pi fourths, okay? Now this 135, 180, if I add 45 to 180, I think I get 225 degrees. So in degrees, this is a 225 degree angle, 45 degree angle. And then as far as radians, it's going to be a 3 fourths, 4 fourths, or a 5 pi fourths radians, okay? So it has one angle, two different names, okay? So then if I go down here at 270, go another 45 degrees, that puts me at 315 degrees. So in degrees, I got a 315 degree angle. But in radians, that's going to be the same thing as 7 pi fourths, okay? So one angle, two different names. Now we have other angles that we want to put in there. We want to put in our special, yes, Faith? That is a 7. That's a bad looking 7. Thanks, Faith. That's a 7 pi fourths, okay? There you go. Now, we also want to put in our special right triangles, our 30, 60, 90 triangles, because those are important too. So I'm going to draw a 60, and I'm not going to draw it exact, okay? For instance, if I were to put 60 degrees in here, it'd be more like closer to here. I'm going to space it out. It's going to be a little bit further apart. It just makes it easy for me to fit everything in. So I'm going to draw this angle. I'm going to call it a 60 degree angle. If I measured it with a protractor, it might be a little less, but I'm going to call it 60 degrees, okay? So in a 60 degree angle, 60 degrees is 1/3 of 180. 60 degrees is 1/3 of 180, so this is going to be a pi thirds, okay? I'd have another 60 degree angle over here. So we'll draw that in. Okay. Draw that in. So I'd go 180 plus, this could be actually 120 degrees. Let's put them all in. Let's put them all in, okay? I'm going to put my, I don't want to get ahead of you, okay? Okay, 30 more. Okay, you guys ready? Are you caught up? Okay, so we got 30 degrees more, which is going to be, well, I don't know if I want to do 30 yet. Let me draw in this one, okay? Draw in this one here. And I want to draw this one in here. And I'll get you caught up once you get them all in, okay? Okay, so you should have all of these lines drawn. These are all my angles. 30 degrees. Boy, 42 minutes to do this lesson. We'll see if I can get it. Okay. All right, 30 degrees is going to be 1/6 of 180, so this is pi 6, okay? This is a pi 6. Now, we're going to go 30, 60, 90. So I got a 30 degrees, another 30, another 30, another 30. So this is going to be, ready? 1, 6, 2, 6, 3, 6, 4, 6, which is 2 pi thirds. This is going to be 5 pi 6, which is 150 degrees, okay? Same angle, two different names. Okay, so then another 30 degrees puts me at 210 degrees. But as far as radians, it's one more 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7 pi 6. Okay, and then I go another 30 degrees and I'll be at 240 degrees as far as degrees. And I'll have a 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, which reduces to 4 pi thirds as far as radians. Okay, it's an angle with two different names. Okay, then I'm going to go from here another 30 degrees, puts me at 300 degrees, and I'll put 330 degrees here. So these are my degrees going all the way around the circle. And as far as what are the radian equivalents, well, this one is going to be 5 pi thirds, and then this is 11 pi 6. Okay, this is our unit circle. We want to keep this because we're going to use this to do a lot of problems. Okay, so what is this? For me, in red, I have my radians. These are angles. Okay, here's a 90-degree angle, or it's a pi halves angle. Here's a 30-degree angle, or it's a pi or 1 pi 6 radian angle. Okay, now we can do any angle we want. So let's go ahead and take a look back at our notes. Okay, so we completed the unit circle with all significant angles, but what if it's not a significant angle? Well, that's okay. We've got some things to do. So first of all, using the unit circle, convert the following angles to radians. So let's take 120 degrees. So if I go to my unit circle, 120 degrees is here. What's the radian equivalent? 2 pi thirds. I'm just going to use my circle. So my answer is 2 pi thirds. 2 pi thirds is the radian equivalent of 120 degrees. Negative 30 degrees. Well, wait a minute. Negative 30. Let's see. If this much is 30 degrees, which is pi 6, then a negative, that would be negative pi 6. You okay with that? So this would be a negative pi 6. 400 degrees. Oh my goodness, 400 degrees. 400 degrees isn't on here, I don't think, because I go 360. So 400 degrees is not on the unit circle. I think I must have meant this to be something else as 400, but that's okay. Let's come back to this one, or I'll change it. Let's make this one, 420. That should have been 420 degrees, okay? Okay, 420 degrees would be 360 plus another 60. Does that make sense? This is the same thing as a 360 degrees plus another 60, okay? 360 degrees is 2 pi. So I'm going to go all the way around to 420, which is here. Watch, I'll do it again. All the way around to 420. 360 plus 60 more makes 2 pi plus my pi thirds, which is 2 and 1/3 pi, or 7 pi thirds. I like 7 pi thirds better. It looks better, okay? Now example 2. So now we're going to take, these are my radians. Let's use our unit circle, okay? Use our unit circle. And then convert it. So 3 pi fourths. 3 pi fourths. There it is. That's my radian. What's the degree? 135 degrees. So same angle. One is in radians, one is in degrees. How am I doing? Is this making sense? Have I lost you completely? Nobody's going to admit to anything, huh? Okay. Pi halves. Well, pi halves is up here at 90 degrees, right? Pi halves, there's pi halves, 90. So a negative pi halves would just be a negative 90 degree angle, okay? Now 7 pi thirds, luckily I did that one for you up here. 7 pi thirds turned out to be a 420 degree angle, okay? All right. How am I doing? Now example 4, find two angles, one positive, one negative, that are coterminal. 130 degrees. Well, let's see. Let me draw a picture. Do you mind if I draw a picture? Draw a picture. 130 degrees is about here. 130 degrees is about here. I'm guessing at 130 degrees. So if I were to go and spin, I want everybody to watch. If I were to spin to here, 130, I could spin all the way around and come back to the same spot. You okay with that? I could spin all the way around and come back to the same spot. And if I spun all the way around, I'm adding 360 degrees, right? So I'd say, okay, another angle would be simply my 360 degrees plus my 130, which makes a 490 degrees. Another way to think about this is your car and a tire on your car, right? And you spin it all the way around. Say you got a nail in your tire, and you spin it all the way around. Same exact spot, but you had to spin it all the way around. That's all I did, is spun it 360, okay? Now I could also spin it backwards, right? So I take a look at my tire, and I got to spin it backwards, so I could take my 130 and spin it backwards 360 degrees. Oh, it's at negative 230, probably 360. Hold on. 130 minus 360. Yeah, or negative 230 degrees. Okay, all three of these angles are putting the nail in your tire directly in front of you, right? Does that make a little bit of sense? Now with B, it's the same thing. 5 pi 6, of course, from a unit circle, 5 pi 6 is about there, okay? So draw a picture. Okay, 5 pi 6 is about there, okay? I'm going to do the same thing. I'm looking at it, I'm going to spin it a full circle. But when I spin it a full circle, in radians, I spin it 2 pi, okay? When I spin it a full circle, I spin it 2 pi. So I'm going to go, is go 5 pi 6 plus my 2 pi. Well, let's see. Might be nice to have a common denominator. That's the same thing as 12, 6, right? 12, 6, which gives me an answer of 17 pi 6, okay? So let's spin it all the way around. And then we can go backwards too. We can take that tire and say, okay, well, let's spin it backwards. Let's take our 5 pi 6 and spin it backwards. Now that means we got to go backwards one full revolution, which is 2 pi, right? 2 pi is one full revolution. So we take it back, 2 pi. I'm going to need a common denominator, so let's make that 12, 6, right? And then I get a negative 7 pi 6, okay? How am I doing? We just have to get used to that radians are angles, okay? All right, turn the page. Okay, now, not everything is on the unit circle, right? For instance, I had that 400 degree on accident, which I meant to put 420. So if it's not on the unit circle, what we do? Well, we've got to have a formula, okay? So if I want to go degrees to radians, okay? So that means I'm going to take my radian, degrees to radians, my radian would equal. So you got to take your degree, whatever your degree is, over 180 times pi, okay? So an example, we'll do the example. Got 100 degrees, let's use the formula. Super easy, honestly, super easy. Okay, so here's my formula. I'm going to highlight it, okay? Here's my formula, okay? So I'm going to take the radian equivalent. The radian equivalent would equal, well, 100 is my degree. 100 over 180 times pi. Now, if it will reduce, I'm going to reduce it. If it will reduce, I'll reduce it, okay? And this one will reduce. If I reduce by 10, and then by 2, I'm going to get 5/9. If I reduce it, I'm going to get 5/9 pi. So 100 degrees and 5 pi ninths are the exact same angle. One's in radians and one's in degree, okay? Now B is going to be different because it won't reduce, but I'm still going to use my formula, okay? So I'm going to take my formula and I'll put my 112 in for my degree, right? So, okay, my radian is going to equal my 112.26 divided by 180 times pi. Okay, now that's not going to reduce, so we're going to get a decimal equivalent, okay? But decimals aren't going to be too bad. 112.26 divided by 180 times pi, and I get an answer about 1.96. We'll say 1.96, okay? So it's about 1.96 radians, all right? And that's an angle, okay? I'm going to go back to our unit circle and think about this. This is, you ready? This is 3.14, okay? 3.14 as a decimal, that's okay, right? That's about 3.14 as an angle, okay? It's about 1.96, okay? Now, if we want to go the other way, we want to convert, if we want to take it to degrees, our degrees are going to equal just the reciprocal. So it's going to be 180 over pi.
Question.
Yeah, yes.
Someone's calling me, and I'll answer it.
Yes.
I apply for a job.
Yes, take it out in the hall, sure. Okay. So, all we're going to do is just take the opposite. So if we want to change it to a radian, 2 degrees, we'll take 180 over pi times our radian. Okay, so let's try and figure out how we do number 7. So 7, here's our radian. Put that right there, okay? So we're going to go, our degree equivalent is going to be 180 over pi times 7 pi 12, okay? Now I can do some things on this. I can cancel my pi's, right? And what is 180 divided by 12? And I can answer about 15 degrees? No, 180 divided by 12. Oh, I forgot to multiply by 7 times 7. My bad. I knew that was wrong. 105. So it's about 105 degrees. So this is the same thing as 105 degrees. Now, 2.7. 2.7 is an angle actually over here somewhere, because know that's about 1, 2, and 3.14. So 2.7, believe it or not, is an angle over here. Let's find out what it is. Just use our formula, okay? So our formula is going to be, put my degree is going to equal my 180 over pi times my 2.7. Okay, now, all right, 180 divided by pi times my 2.7. I get an answer about 154.7. That's kind of what I thought over there somewhere. About 154.7 degrees. Okay, and we'll talk about minutes tomorrow. Okay, so that's all I have. Okay, I would strongly suggest that you use your unit circle to help you. Okay.